Greetings, everybody. Today we're going to look at dividing polynomials. We're going to attack dividing polynomials, which is kind of a hard task. But if we break it down into pieces, again, it's not too bad. Let's start. So there's our learning target. Determine the quotient of two polynomials. But before we do that, we're going to start with a simpler example, something you learned in elementary school. How you divide 1372 by 25. So let's go ahead and get started here. So remember, you put what we call our divisor on the outside, and our dividend is what we call this piece. And then our answer, of course, is going to be our quotient. So we're going to have a quotient for an answer and possibly a remainder. So those are the two things we're looking for. Okay, the first thing we need to recognize is that 25 does not divide into 13. So we have to go up to 137. So we're looking at that piece right there. Okay, so how many times does that go into 137? Well, would that be 5 times? So let's put that up here. So we got it goes in there 5 times. And then we multiply 5 times 25, which gives us 125. And then remember, we subtract that piece off. So when we do that, we get 12. And then we bring down whatever's left over that we didn't use. And then we repeat the process. So we're going to ask ourselves, how many times does 25 go into 122? So we're going to do that. So 25 goes into 122 4 times. And again, we multiply to get 100. And then we subtract. And we get 22. Now at this point, 25 does not divide into 22, so we stop there. That's our remainder at the end. So our quotient is 54 with a remainder of 22, and we typically write that as one number. So it's 54 and 22 over our divisor. So remember that you put your remainder over your divisor like that. So, and if we did this on the calculator, you get 54.88 if you wanted to check your work there. So that's just a reminder how we do long division. We're going to go through the steps with polynomials next. Okay, so here is our example. We want to divide this polynomial by x minus 5. Okay, so we're going to set it up like this. Now notice there's no x term in this expression here. So I'm talking about the dividend there. There's a missing x term. It goes from squared to constant. So in our dividend inside our division symbol there, we're going to put a placeholder for the x term. We're going to use 0 as our placeholder. Okay, so let's get started. So we're going to start out by, we're only going to focus in on this piece right here, the x part when we're dividing by binomials. So we asked the question, how many times does x go into x cubed? And if you're having trouble seeing that, we're just going to write out a subproblem over here. This is really what we're doing. We're dividing x cubed by x. And remember, x is to the first, and that gives you x squared, because remember, you subtract your exponents when you're dividing. So our answer to that is x squared. So we need to place that above the x squared term like that. Okay, great. Okay, so our next task, now we got the top part. Remember, now we need to multiply. So we're going to multiply x squared times the entire divisor there. So x squared times x is x cubed. X squared times negative 5 is negative 5x squared. And I'm going to put that in parentheses because we're going to do our subtraction stage here, but we're subtracting both pieces. This is the more complicated part versus numbers. Okay, so I'm going to do x cubed minus x cubed. Those will always cancel in this kind of problem. That's how we set it up. And I'm just going to do, so this next piece I'm going to highlight really carefully here to point out. We're going to be doing negative 7x squared minus negative 5x squared. So we're really adding 5x squared. So here in this spot, we get negative 2x squared. Again, we're doing negative 7x squared minus negative 5x squared. I'll go ahead and get rid of some of this notation here, make this a little more clear. Okay, good. Okay, so now at this stage, remember our next step is to bring stuff down. Okay, so we're going to bring down the 0x. We're going to bring down the plus 14. And we're going to go back to division again. Okay, so we're going to say how many times does x divide into negative 2x squared? Again, if you have trouble seeing that, write out a subproblem over here. We're dividing negative 2x squared by x. Okay, well that goes in there negative 2x times. Okay, So we're going to put above the x term, we're going to put negative 2x. And now we're going to multiply. So we're multiplying the negative 2x times the divisor. And we'll put that under here. So again, you always end up with the same piece underneath this first term that you started with. And then we're going to do negative 2x times negative 5, which is plus 10x. And we're going to put it in parentheses. And this is where students, when they first start this process, make their mistakes. Remember, your first terms will always cancel. Negative 2x squared minus negative 2x squared is really like adding 2x squared to negative 2x squared. So that cancels. And then I'm doing 0x minus 10x. So I get negative 10x there. And then I bring down the plus 14. Okay, and then we're going to repeat the process again. Let me get rid of this over here. Okay, so we're going to go to, let's use orange here. Actually, we're going to use, yes, orange will work. Okay, so now I'm asking the question, how many times does x go into negative 10x? So again, if you need to see it as a separate problem, it looks like this. And the answer to that problem, of course, the x is canceled, leaving you negative 10. And we're going to put that above the constant term up here. And then we're going to multiply. So we're going to multiply our divisor, x minus 5 again. Okay, so here we go. Let's see, we're going to use green here. So we're doing negative 10 times this divisor. So we get negative 10x. Notice we get the same thing again. The first term there. It always happens. Negative 10 times negative 5 is positive 50. And remember, we're going to make that a little bit cleaner there. So positive 50. And we'll put that in parentheses, and we're going to subtract. And when I do that, my first terms cancel. I'm doing 14 minus 50, so negative 36. Now, I can't divide negative 36 by x, so this is my remainder. So how do we write our final answer? Well, we take our quotient, which is up here, and just write it out. X squared minus 2x minus 10. And then we have this remainder of 36, and it's negative, so I'm going to write negative 36 over the divisor, x minus 5, like that. And that is my final answer. If you're asked for the quotient, it's the part on the top part. So your quotient's up here, and your remainder is down here. Okay, the next thing I'm going to cover is what we call synthetic division. As you can see, long division is cumbersome and it's time consuming. Sometimes that's the only option we have. The last example, we could have also applied this method, which is called synthetic division. Now, the problem is the divisor, you must take note of this, the divisor has to be in the form x minus k. So you can do things when it's x minus 3 or x plus 5 or x minus 8 when these are the divisor. Now remember what those are. The divisor is the part that you're dividing by right there. So as long as it's x plus a number or x minus a number, we can use synthetic division. And in fact, I think you'll find it's a pretty easy process if we do a couple problems. Okay, so the first thing to notice that I want to point out is right here, notice it's x minus 3 for our divisor. We change the sign of that. Whatever it is, switch the sign. Okay, so that's your first setup. So you're going to set up the problem. Okay, your dividend, the part we're dividing into, is going to be right here. And notice that's where this is coming from. Now you may say, okay, there's 5 terms there, and there's only 3 terms over here. So what gives? Well, notice we've got a couple placeholders. If we look at this piece here, we got x to the 4th, and if I were to write an x cubed term, it would be 0x cubed. And then I've got a squared term, which is minus 13x squared. There is no x term, so if I were to write it, it would be 0x, and then I got a plus 32. So that's where these numbers right here are coming from. We need a placeholder for this cube term and the x term, and that's where these zeros are coming from. Okay, so this is kind of shorthand, if you will, for long division. Again, it only works for those special cases where we have this kind of divisor. Okay, so that's your first step. Let's go to step 2 here and see what it looks like. Okay, so now that you have everything set up, the first thing you do is you're going to bring down that first number, whatever it is. You just bring it down. That's the first step. All right, let's look at our next step. Okay, the next thing you do is you just do a multiplication and add thing. So notice this first number here, we brought it down. So we brought down this 1 here, and then I do 3 times 1, which is 3, and I'll put it right there. And then I add these two numbers to get this 3. And then I repeat the process. Let me use a different color here. So my next step is to do 3 times 3, which is 9, and then I add there to get negative 4. And then I repeat the process with a different color here. We've got 3 times negative 4 is negative 12. And then I add those two to get negative 12 here. And then repeat one more time here. We're doing 3 times negative 12, which is negative 36. And then I add those two to get negative 4. Now, that's a little messy, so let's now go down and look at the little cleaner version here. You can see all the steps here. Okay, so down here, right here is everything we need. And we're going to, on the next slide, we're going to look at how we write our answer. So just to repeat, we're going to bring down the first number, multiply to get that one, add. Then multiply to get that one, add, and then repeat the process. Okay, so how do we get our final answer of that? Well, you'll like it's pretty straightforward. You're basically, since we're dividing by x minus something, we're going to be dividing by 1 power of the x. Remember our original problem had x to the 4th? So whatever this first number is here, it's going to go with this, a coefficient of 1, and it's going to be 1 less than what we started with. So we have x cubed there. And then this number, the 3, is going to drop it to x squared. And this negative 4 belongs with the x, and that's why we need those placeholders. And then the negative 12 is a constant term, and then the last number is your remainder. And I'll show another example at the end of this video where I do long division and synthetic division. Okay, so I'll pull one of our Khan Academy problems here. This is the one we're multiplying by binomial divisors. Okay, so I've set up our long division problem over here to the right. We're after the quotient and the remainder. So remember our first step here is to see how many times, or what is the quotient when we divide x into x squared. And that works. So we're kind of thinking x squared divided by x. So the first is going to be x. So I put the x above the x term there. And then I multiply the whole divisor by x. So I get x squared minus 2x. Now again, put it in parentheses and subtract off the whole thing. Again, first terms cancel. I do negative 7x minus negative 2x. So I'm really adding 2x to negative 7x to give negative 5x. Bring down whatever's left there, and then repeat the process. Okay, so we've got, in this case, we're deciding how many times does x go into negative 5x. So again, think about it like this if you need to. And of course, the answer here is negative 5. So I put that above the constant term, and then I multiply. So I do x times x, which is, or negative 5 times x, which is negative 5x, and negative 5 times negative 2, which is positive 10. Put parentheses around it and subtract. Okay, and when we subtract, of course, my first terms cancel, and I'm doing 15 minus 10. So this answer here is 5. Okay, and I can't divide x into 5, so I stop there. This is my remainder. Go ahead and highlight that here. So remainder is here, and my quotient is up here. So my quotient in this case is x minus 5, and my remainder is 5. Now, if we were to write that as a polynomial, we would say x minus 5 plus the remainder 5 over the quotient, which was x minus 2. So I could write it like this, or sometimes it asks you the two different parts. Okay, so our final answer is x minus 5 plus 5 over x minus 2. That's using long division. We're going to do the same problem using synthetic division. Okay, so here's our problem. Remember what we do. We take our piece here, our dividend, and we write out just the coefficients. So it's 1x squared. So I'm going to write a 1. And then it's minus 7x, so I'll write a negative 7, and then I'll write plus 15. Now notice I don't have any missing terms here, so I don't need to put any zeros this time. Now remember in this case, our divisor has a minus 2, so switch the sign. Now remember, first step is you're going to bring down the first term that's there. In this case, it's a 1. And then I do 2 times 1 is 2. I'm going to add these together to give me negative 5. And then I'll repeat that process again. I'm going to do 2 times negative 5 equals negative 10. And then I add these two together to give 5. Now, we're going to drop down the power of our final answer because we're dividing by x. So we can see that here. See, we're dividing by x to the first. So, of course, it's going to drop that square down when we get our final answer. So this first number here tells me it's 1x. So 1x minus 5 with a remainder of 5. And remember to put that over your divisor, which is x minus 2. So that's my polynomial version of the answer. If you were on Khan Academy, where it splits up the two parts, you would write x minus 5 as your quotient, because that's the part up here. I was thinking long division there. And then your remainder is just 5. Now, a lot of times, you're not going to put this in the con, but the remainder really should be written over the divisor, x minus 2. Okay, so that covers long division and synthetic division. You decide which one is easier. Again, sometimes we can't use synthetic division. I'll give you an example real quick before we close out. So if we're going to look here, you cannot use synthetic division for something like this. If I was dividing, my divisor looked like this. Because of the squared, it doesn't matter. X plus 5. I can't use synthetic division. I could if it was x plus 5 or x minus 5, but I can't because of the squared. Okay, so I hope that helps. Enjoy your long division. We'll practice that in class. Have a great day.